this is Drew Thomas, on that one of the big changes for between last year's FOA and this FOA is that we have combined all the materials areas into one topic area. And so we'll have multiple different program managers and representatives representing the different materials areas to provide an introduction on kind of what their role is, anything that they may think is important to highlight before we open up for questions. But I think we can start the overall question and answer with our Advanced Materials Manufacturing Technologies Program Manager, which is Dirk Cairns-Gallimore. And then Dirk, if you wouldn't mind just kind of passing it around the horn to Sue, Ming, and Kimberly as we introduce everyone.
Excellent, thank you. As Drew mentioned, my name is Dirk Cairns-Gallimore. I am the Federal Program Manager for the Advanced Materials and Manufacturing Technologies effort within the Office of Nuclear Energy's NE7 group. We're really focused on structural materials and materials that do in reactor environments. And as the program expands, we'll be looking into novel shielding materials as well. But in this area, we're looking at pretty much the entire spectrum of kind of applications. So from data analysis, modeling and simulation capabilities for advanced manufacturing processes themselves, NDE. So really all the nuts and bolts for qualifying these materials and predicting their performance in the future in reactor environments. So for those end applications. So we're really looking at a broad spectrum of all those things. So we'll take questions on that later, and I'll pass it off to Sue Lessica.
Thank you, Dirk. So in my area of interest, first I'll start with light water reactor materials. As the Federal Materials Pathway Lead for the Light Water Reactor Sustainability Program, areas of interest for me are understanding the materials behavior under the long-term operation for our light water reactor fleet in order to maintain the fleet and continue their safe and efficient operation. So this includes understanding degradation effects, monitoring materials, and mitigating and repairing materials. And the type of materials of interest include metal alloys, concrete, and cable. So that's for the light water reactors side. On the advanced reactor side, the materials of interest in particular are graphite related, understanding graphite's behavior under reactor operation conditions. So this includes irradiation effects, the effects of stress, time, temperature, in addition to the effects of coolant on graphite. And graphite is of interest in both MSR reactors and the gas-cooled reactors, so helium and molten salt environments. The other advanced reactor materials interests fall under Dirk's scope that he's already covered, and the graphite would fall under me. So next, Ming, why don't you take it away for cladding materials?
Thank you, Sue. Hi, good afternoon. My name is Ming Tan. I'm the program manager at NE43. The program manager we call it Innovative Nuclear Materials. The mission for this program is to develop next generation fuel cladding materials and in-core materials. And also we will address nuclear materials recycling and reuse. We are trying to maintain long-term nuclear materials sustainabilities. So for the innovative nuclear materials, we have several focus areas. One is the materials design. Materials design, we care about the new materials like the novel metallic alloy and all the new coating materials. For the materials, second area is materials performance. we consider the extreme condition because field collating materials is the in-core materials. We face to the neutron radiation, so radiation damage and the corrosion outside of the collating face to different coolant. So corrosion is also we are consideration. The third focus area is materials fabrication and manufacturing technologies. We are looking for some new or different technologies to fabricate new materials or existing materials. So for the CINR technical area 11, actually the number 4, the fourth paragraph in the topic area description, the fourth paragraph is related to this program, Innovative Nuclear Materials. Proposals are looking for support the development and calculation of innovative fuel collating materials for fuel cycle applications. Specific interest in these areas, including the material design, new metallic alloy, and the new coating materials performance under extreme condition, including the fuel element to cladding interaction, cladding materials to coolant interaction, high temperature, high dose, and corrosive chemical environment, and materials fabrication and manufacturing technologies, and test calculation capabilities. So this is a subtopic areas for the innovative nuclear materials, and we are focusing on the fuel collating materials. If you have any questions, please let me know. Next, we just pass to the Kimberly. Kimberly.
Hi, my name is Kimberly Gray, and I'm the Federal Program Manager for the off-gas capture and waste form development areas within NE 43. I have 2 calls in this section, in this topic area 11, and that would be in paragraphs 5 and 6. The first is in the off-gas capture area. And in this proposal, we're looking for materials that can effectively capture and immobilize volatile chemical species during the recycling processes. The specific chemical species that we're looking at, of course, is iodine 129 and krypton 85. The second proposal, we're looking at the CERMAT waste forms. As you can see, the CERMATs are composite materials that are composed of ceramic and metallic phases that possess novel properties such as flexible capacity, high thermal and electrical conductivity, extra waste loading, and robust durability and efficient fabrication. For these 2 proposals, I have listed references that you might want to take a look at. And if you have any questions, of course, you can ask us here today, or you can send us an email on the NEAP website. Thank you.
Thank you to all the program managers for introducing those topics. We're going to open up to questions.
All right. What we'll do is wait for a couple questions here if you all have any. Just want to extend a couple of reminders. The first is after this session, if you have questions in the materials area, you'll reach out to the integration office and we will direct your question to the appropriate program manager, national technical director. That way we can get you an appropriate answer. Those requests typically are answered in 24 to 48 hours, right around those time frames. So don't wait too long to where you're at the due date. As a second reminder, the pre-application due date is June 26th. And for this area, it is required that you have a pre-application in to be able to apply at the full application stage. So just remember to do all of those things. And I think we'll turn some time over to questions at this point if people have their questions formulated. So we'll hang on for a couple minutes until the questions are over, then let our program managers go.
It looks like there's a question in the chat. I have a novel seal design that would be applied to supercritical CO2 power cycles. Would it fit in this topic area?
I'll take a shot at answering that. This is Dirk. I think it could. It's really going to depend on where it's at in respects with the rest of the balance of the plant. So where it's at in the reactor system. More than likely, we'd be interested on it if it's on the side where on the reactor side, but not necessarily if it's just in the power machinery.
Another question for off-gas capture are materials that capture both krypton, let's see, I and KR of interest, or can the materials be specific to individual species? Also, is the focus primarily the baseline materials as identified in the references?
Yes, we're definitely interested in Krypton 85 and or the species that are listed in the references. Krypton 85, specifically Krypton 85 and iodine 129. And there are other species that are listed in the references.
Great, thank you so much. Another question. Would it be of interest to develop structures that are resilient to stress corrosion cracking, specifically modification of microstructure to make the base structure less susceptible to SCC?
Yes, those would be of interest too. I think the AMMT would be interested in that, and I also suspect that LWRIS might be interested as well.
Another question.
Sorry to speak for you, Sue.
No, not a problem, Dirk. I think that since it would be a new construct of material, it would probably fall under your program, since it wouldn't be a repair, unless it would be for a repair, and then it would fall under to me. But either way, it is of interest to us under this topic.
Another question. Regarding the synergy between irradiation damage and mechanical loading, is there a priority toward investigating existing code qualified alloys, possibly extending their regimes, alloys currently under qualification process, or novel alloys?
All the above?
Yes, we're currently doing work in all of those areas, so they're all of interest.
Great, thank you. We have another one coming in that has a couple questions. The first is, regarding structural materials, how do we address characterizing materials for radiation? Do we need NSUF access, or is it okay to characterize it in microscale using small radiation source?
We've seen projects that have done both of those kinds. So we've seen the micro samples, and we've also seen those that have requested NSUF access. So both can be done.
Okay, this might go along with that. Do R&D projects, can R&D projects be done without NSUF?
Yes.
One other thing I will add is, as far as the irradiation, is NSUS also has a materials library. So it is possible that we have whatever material you have interest in already irradiated in that library that you could then do your characterization work. So perhaps you don't even need to do an irradiation if it's something that falls that's already available through the NSUF library. And if you have funding through this call, you can get access to that library. The NSUF website has the library database, so you can see what is available through the library.
And I would add that just for reference, the large majority of projects in the materials area that are funded through this funding opportunity don't have NSUF access. So there is a variety of different ways that you can either engage with NSUF or do research that's outside of a larger irradiation style project and have success.
Yeah, and to add on that, I mean, we've got plenty of different projects and irradiation is not a requirement here either, because there's areas of corrosion, NDE, there's new materials development, and even different fabrication methods that are in here as well. So
great, thank you guys. Another question, does real-time monitoring of additive manufacturing fit this topic area? If yes, DOE is interested in monitoring system I'd say, is DOE interested in monitoring system development or sensor hardware development?
So there's a number of different areas of work in this area. So yes, we are interested in it. Um, I will pass on the website to Drew so that he can post it. But the AMMT has recently established its own website, so we do have information on the work that we are doing in that area. So it'll behoove folks that are interested in that to make sure that we're not kind of doubling up or doing different similar processes. So I'll make sure that that information gets passed on to our NEUP folks, and that's posted to the appropriate site.
Another question, does mechanical performance of degraded concrete components fit in this topic area?
It does, yes.
While people are thinking of questions, just to point out, Drew has put in the NSUF Fuels and Materials Library as well as the AMMT website. So those links are there as well. Okay, I see a hand. Go ahead and unmute yourself, ask your question.
Warren Alexander of The Ohio State University. Would development of new alloys for additive manufacturing of reactor components or compositional optimization of existing alloys for additive manufacturing of new reactor components be of interest?
Yes, they would. Both topic areas of interest to the AMMT.
Thank you.
Okay, we have another question. Does NDE of light water reactor components for embrittlement with no focus on manufacturing still fit within this topic?
Yes, it does, absolutely.
Okay, thank you so much. Oh, here's another one. Does repair of reactor structural components fall in this topic area?
It does, yes.
Yeah, and I think this brings up a good point as we're getting these questions. This is really what I would call a big tent for nuclear materials and additive manufacturing materials across the board. So there's a lot of these spaces that are probably of interest as we go forward, rather than having separate materials type scopes like we have in the past.
Hey, we have another question. Do materials suited best for advanced reactor concepts best fit here or in topic area 1?
Taking a quick look at the topics, I would suspect that they probably fit better within this topic area.
Yeah, the way that we have kind of been guiding people in these cross-cutting areas like materials is if it's really focused on, like in this case, if it's really focused on the development of the material or characterization of the material, then it likely fits here. If it's really applying the material into a reactor, and it's more focused on reactor performance or those types of analyses, then maybe it's better for topic area 1. So, think about, is the core research project materials focused, or is it, reactor analysis focused or something like that? And that may give you an indicator of where to put it. What I would say is that regardless of where you put it, we will be looking at that exact question, talking with program managers to make sure that we have the right folks engaged on any particular topic. So whether that's moving the application to a different topic area or engaging program managers and other technical reviewers across multiple areas, we take that into account over the course of the review process.
Here's another question. Will capture and separation of Krypton
Krypton and xenon.
and xenon. Thanks.
Yes.
Thanks, guys.
Yes.
Fit this topic area.
Yes, it does.
Another one coming through. Regarding structural materials, is it applicable to include undergraduate student training with degrees not related to nuclear engineering for this call, or is it better to just not address that?
So I'll take this one because I think this is more of a NEUP style question. We do, as part of all of these CINR projects, have the ability to request a supplement for research experiences for undergraduate students program. You can either include that type of an offering or just include undergraduate researchers in your research as part of the overall research budget. When we're talking about degrees not related to nuclear engineering, when we talk about those types of degrees, we talk about nuclear energy research topics, which is broader than nuclear engineering alone. In this case, there clearly there could be a material science, mechanical engineering, those types of degrees that are related, but may not be exactly a nuclear engineering degree. So to be clear, this program is not only for nuclear engineering departments, it's for nuclear energy related research and development, which, because they're complex systems, span a lot of different, areas of expertise. So I hope that helps. If you have a follow-up question, feel free to reach out to the integration office and we can help you navigate those rules.
Let me just add, Drew, this is John Gilligan. Almost half of the awards that we make go to non-nuclear engineering disciplines. So yes, could include material science, chemical engineering, mechanical, chemistry, physics, etc., and the students related to those disciplines as well. So absolutely.
All right, I'm not seeing any other questions. So as CC mentioned, these will be, the session's been recorded. It will be put back up on the web. It looks like we do have one more question, so we'll hang on for that one.
For purchasing equipment that is 50,000, is it possible?
Yeah, I'll answer that one as well. From a NUP research and development space, the overall research and development project can support some equipment purchases to be able to facilitate the research. So that's not you can read a little bit more about, the guidelines and the restrictions from the funding opportunity, and reach out to our office if you have any questions that are more specific. But yeah, equipment purchases are okay. It's part of the research and development grant. All right. With that, we'll wrap things up. We do have a slate of sessions tomorrow as well on a variety of different topics. Look forward to seeing some of you there. Really appreciate Dirk, Sue, Ming, and Kimberly, your attendance here and for you being able and willing to answer questions. So thank you for your participation, and we look forward to seeing all of your applications here soon. Take care, everyone.